intentionally waiting until they actually need this particular tool, which is a novel, let's call it a novel approach. So on the production side, resistance to herbicides, resistance to insects, resistance to diseases. That covers 99% and then some change of genetically engineered crops that are produced in agriculture in this country and elsewhere. And it's that short list. Certainly corn, soy, cotton, canola, eggplant, and those types of things. But it's not an infinite list, and it is mostly focused on commodity crops, not crops, we might call them high-value crops or specialty crops, but I'm really saying they're not generally fruits and vegetables. It's changing a little bit. This is a potato. I'm always curious where they come up with the names for these things. It's called innate. I don't know why. And again, this is an interesting, and I kind of can step back and look at these with my intellectual hat on a little bit. It's like, okay, this is what this is. It's genetically engineered. It's not transgenic, so they didn't take genetic material from something else and move it into this organism. And the advantage is partly aesthetic, that when you cook this at high temperature, in other words, when you make French fries or potato chips out of it, you boil it in hot oil, it doesn't brown. And you could look at that and say, okay, that's interesting. Do we really care if it's brown or not? In fact, we do, because part of the browning over here is acrylamide, which is a carcinogen. So they don't advertise it that way. The way they're advertising it is that people are less likely to throw it away. So it's almost a food waste story. I'm ambivalent about which story they use, but it's a nice kind of interesting case study, and it's not on the input side. It's facing you. It's facing you as consumers. And then you have to make decisions. And I don't believe that this is like in the potato supply yet, but I think by 2018 it probably will be. A similar one is apples. Arctic is there's a little TM. This is a trademark name. It's called Arctic. Same thing though. It's a non-browning apple. And the market for this isn't necessarily, I don't believe, an apple that like you would just go buy an apple and chomp down on it. It would be going into a store or going into an institutional food setting where the apples are already cut up and they're in some kind of container, is that it wouldn't brown nearly as quickly because they oxidize when they're exposed to the air. So again, a consumer-facing trait. There's one that was a little bit novel in that it was developed at a public agricultural university. There's now a mushroom, so that's not a plant, I know. It's fungi, but anyway. It's that they have one that also, when you cut mushrooms, particularly like the white button mushrooms, they turn brown relatively quickly. But a scientist at Penn State actually genetically engineered to be slower browning. These are not, they're not transgenic. So these use the new kind of array of technologies that are available that go, they're actually different technologies or different methodologies, things like RNA interference. Don't ask me how it works because I don't know. CRISPR, which is an acronym, don't ask me to spell it out because I can't remember it, but it's on a slide later, so you can get it then. And these are, they're essentially editing genes at that level, turning genes on, turning genes off, which in terms of nature is really not that novel. That's not unusual. And I think I have a picture of a bunch of brassicas that will bring that to light here in a minute. I'll just point out that the C is commercial and the D is developed. So you can see there's a bunch of stuff over here, but these are input traits and output traits. And notice that the output traits are mostly in the future. But some of those, the future is upon us, if you will. They are either in the food supply, or they will be very soon. And many of them are, most maybe, are not transgenic. They are gene editing, which is apparently remarkably simple to do. I mean, I would be shocked if some aspect of things like using CRISPR is not included in some high school biology labs. It's that easy and cheap. So the future is uncertain, shall we say. I didn't pack a bunch of data in here, but I just want to illustrate. So this is time, 1996 to roughly 2013. And this is the percent of acres planted. Soybean, HT is herbicide tolerant, and herbicide tolerant cotton, etc. I'll just say this, that it was adopted very, very quickly by farmers in this country and in other countries where it's available, to the point where herbicide-tolerant soybeans is probably somewhere now up 97, 98% of every soybean acre planted in the United States is herbicide-tolerant, genetically engineered. So because I spent a lot of time working with farmers, I still talk to a lot of farmers, there has to be some valid reasons for them to do this. The idea that they've, kind of had the wool pulled over their eyes and just went into this without thinking about it, I think is probably false. I've asked some good friends of mine who grow a lot of corn and soybeans about this, and they have specific reasons of why they adopted it. They also have maybe specific frustrations about not so much the technology, but kind of the corporate consolidation around the technology, where it's just, there's not a lot of innovation there. This just tells you where other things are going on. So obviously we're up here in the US. We do a number of crops. If you go to Brazil, the way they produce soybeans in Brazil is basically a system that was exported from the United States. So they grow it in a very similar way to the way we do it in Illinois and Iowa. There is, on the kind of, this is something we talked about and had guests in to talk to us about on the committee. This poses some really maybe interesting and circumstances where you really have to think clearly about what the potential impacts of having this technology might be. And one example that I'll give that we talked about it on the committee is right here in Bangladesh. And there was some work, well, it's ongoing. There's a BT eggplant native to Bangladesh called Brinjal. The Brinjal would be the local word for the eggplant family. And it has the possibility of reducing the number of spray applications these are smallholder farms with very low capital and things like that, where they might do 40 or 50 chemical applications, and it has the possibility of eliminating those applications. So this is, then you start asking the question of, what's the trade-off here in terms of positive public health impacts for those smallholder farms? And that's why we had people come in and try to just like walk us through this. And this isn't just about, does it work? Does it control the insect? It's like, what are all of the other issues that are connected to this? And we took a somewhat unusual approach that we actually talked about those other issues. It wasn't just, does it work? Does it control those insects? And that was a very interesting experience. More data, it's kind of like blah, 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 blah. They're pie graphs. We'll skip that for now. Come on, it's 8 o'clock. Do you really want to look at pie graphs, or do you want to look at pie, right? So the history of these being available both to farmers, the people and farmers, but maybe not ranchers, but people who grow crops, is pretty short. As I said, I worked for Cooperative Extension right when these came out into New England. That and recombinant bovine growth hormone, which they inject into cattle, but it comes from a modified bacteria, and it was only 20 years ago. So all of the things that we have seen and that the conversation has been around is really just that 2 decades. It's almost exactly 2 decades. And you know, pick your viewpoint. There are many risks and benefits, and we use this word repeatedly on the committee about purported. It's that certain viewpoints say this is what is happening, this is a potential benefit, it's all good, it's all bad, and we actually made an effort to listen to people and organizations across that entire spectrum, which had the expected outcome is that everybody was mad at us. It's like, c'est la vie. You can be mad if you want. Tomatoes were actually, a few of you, do you remember Flavor Saver tomatoes? Yeah, right, 1994, 95 came out, genetically engineered so that it would last longer on the shelf. And originally carried a price premium, so it could sit on your shelf and taste bad for even longer. But it only was on the market for maybe 3 years because the ripening actually is what makes tomatoes taste good. So, so this was actually the first one, but there is this range of benefits, potential benefits and potential risks, and we tried to at least be fair-handed in evaluating those. So this is like categories of things that we looked at. Agricultural impacts, which is partly about how much is produced, but also, you know, for farmers, it's not always about how much, it's how. So some of these technologies are labor savers. It makes the act of producing those crops easier. So it might not produce more corn, but if it produces the same amount, but it takes less of my labor, that's a benefit to the farmer, right? Environmental impacts, potentially both positive or negative, not either or, but both. The same with ecological risks. Potential health impacts, which could be from the genetic engineering, but also the example I gave about if it displaces something that's much more toxic, that could be a public health benefit. And then this we kept coming back to, and that is, are these outcomes, positive or negative, are they unique to genetically engineered products, or is it really just kind of similar to other things that other technologies we see in agriculture? And the answer is both. It depends on which technologies you're thinking about. And then this is a constant source of discussion, a little outside our scope, what we were doing. So I worked with this group. It's a fantastic group. I actually didn't know any of them when I started. My background, my professional track, if you will, is actually in sustainable agriculture. I'm coming out of the Midwest in the 80s. So I'm always thinking about how are different things connected and how are farmers and other producers thinking about those. So it's economic, environmental, social impacts on the food supply, all of those kind of things. So I actually felt really fortunate. It was a hell of a lot of work, a lot of trips. This is the giant statue of Albert Einstein, which is outside of the National Academy right on the Mall in Washington. Made a lot of trips there, but a wonderful, wonderful group of people. And then this is the output. This is we produced this report. You know, long, it's 500 and some pages. We read 1,000 or more papers that we reviewed to do this. So just a couple key outputs. That one, except for certain circumstances, in general, genetically engineered crops don't increase yield. That shouldn't really surprise us. So if you just change one little pathway to get herbicide tolerance, that doesn't mean that now you're going to grow 20% more. We took a lot of heat for this conclusion because obviously the industry didn't like it very much. That's okay. We looked at a lot of evidence. Evidence like this. So, you know, the yield of corn keeps going up. Did it grow up faster after they released genetically engineered corn? The answer was no. The exception to that was if you started using Bt, cotton, but prior to that you didn't do any insect control at all, then of course your yield went up, right? So if it wasn't a replacement of something else, it was that you weren't doing something and now you were. And that was true in some developing countries, actually, but less so in the United States. Did pesticide use change? Again, it depends. More data, but these are weed killers mostly, and it didn't change very much, but the kind of chemicals used shifted. Insecticides, things we use to kill bugs on cotton, for example, went down dramatically, not only in the US, but elsewhere. And some of those chemicals that are being displaced are really, really nasty characters. So there actually has been some studies on public health benefits of those, of that shift in the US. Ecological impacts are kind of variable. In some areas, there is enough, for example, BT corn being grown, that it is suppressing the level of insect damage, even if you're not growing it. So in the group of scientists that study this, they call it area-wide repression, which is, you can think of as a very much a landscape scale ecological outcome. Not just what's happening on my farm on this field because I'm doing X. It is much bigger than that. There's some studies of biodiversity, but not a really strong signal, if you want to call it that. There is the idea out there that suddenly when genetically engineered crops came out, that people just, they were growing 7 crops, but then they came out and now they're only growing corn all the time. We didn't see any evidence for that. Most of the shifts to make more simple cropping systems took place in the 70s and the 80s, long before these came out. And then there's herbicide resistance, which, is amazing when you start reading about herbicide resistance in the New York Times. Like, whoever thought that that would end up in the Times, but it does. And now there are some new products, new crops out there in the market that are, in some cases, we're going back to old technologies. So if anybody's been following the herbicide they've been spraying on soybeans in the Midwest called dicamba, did a huge bit of damage to things like orchards because it drifts. It becomes an aerosol, and then it will go from where you sprayed it to somewhere else. It's been a bit of a nightmare this year, 2017. Generally, either farmers make more money or somewhat indirectly they use less labor. The system for doing things like controlling weeds is remarkably simple. But it's only remarkably simple for that really short list of crops that are included. So we don't have like herbicide-tolerant carrots, right? It's corn and soy and those kinds of things. It depends a little bit on where you are. But in general, income, health impacts, these are the types of things that people were worried about. We had some public health people on the committee that did a deep dive into this. We brought people in. Didn't see any consistent evidence, given the set of products that are in the food supply, that there were negative health impacts to either people or animals. Because think of things like corn and soybeans, that's one of the major markets for corn and soy, and canola meal and things like that is feeding livestock. But there are some studies on this. And pesticide exposure, we actually looked at both sides of that. Are people or other animals more exposed or less exposed as a result of this technology? We as a committee looked at a lot of these, and again, there's not like a really marked signal there, and you can't, obviously that means I can't stand here and say it's perfectly safe, don't worry about it, la 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 la. It's really hard from the science side to say. You can never actually get to a point where you can say the evidence indicates it's perfectly safe. That's something you actually can't you can't prove that. But you also would look for, like, is there a specific marker or signal that says, okay, it's not safe, or it has this particular benefit, and we just didn't find very much there. So we said no pervasive evidence of adverse effects. Or positive effects. Of course, most of this is the input traits. So there aren't enough products out there that are consumer-facing that we would look at it and say, is there an advantage to having produce that doesn't turn brown? That's not even, that's such a tiny part of the food supply right now that we wouldn't be able to say. The next generation, so switching for a few minutes here to the future. Still some more input traits. It's a bit frustrating, the kind of joke, because I've been involved in these conversations for more than 20 years, is that those traits that might benefit all of you as people who eat food are always 5 years away, or they're always 10 years away. I was starting to believe that, and then we're maybe just turning the corner a little bit. Some physiology, this is kind of literally down in the weeds or down in the crops, but like having corn or wheat that could capture nitrogen from the atmosphere in the same way that soybeans do. It's actually the bacteria on the roots of soybeans, which would save us from manufacturing and using, millions of metric tons of nitrogen fertilizer. And then the big question is this one: when will we see the output traits we're seeing so far are, at least in my interpretation, somewhat aesthetic. It's like, what does the product look like? But you could envision where it would be a nutritional trait that could have very specific and well-documented nutrition and health outcomes associated with it. But I don't necessarily see like there's something coming out next year that's going to be there. My hope is that that would be the case. In general, genetic engineering for things like producing drugs is much more acceptable broadly by the public than some of the applications in agriculture. And I think the same would be true on the nutrition side if it was producing, for example, higher concentrations of something that we know is good for us. These are just I mentioned these earlier, the methodologies, RNA interference. We'll take a short quiz here in a few minutes where you'll be asked to reproduce this.